This is where we left off at the domain and range of this particular situation. Everybody was able to ascertain the fact that the pay depends upon the hours worked. Now, some of you who have jobs in the 21st century work at establishments that require you to go to some kind of piece of technology and enter the time you arrived and enter the time you leave. Those businesses are often paying you down to the minute. So if you get paid $10 an hour and you work for 12 minutes past your hour, you are going to be paid an extra $2 because the computer does the work, right? When I was your age, we did not have that option. You were paid what your time on the schedule said you were paid. So if I was scheduled to work at Subway from 11 till 7 o'clock, I got paid for 8 hours that day. I was not paid for partial time. If I was sent home early, the best I would get was rounded off to the nearest half hour and never downwards. Does everybody understand? So if I worked 11, or if I worked from 11 till 6:37, I would have been paid from 11 to 6:30. Understand? You were never paid for any extra past that half hour. The manager, the owner of the Subway I worked at, couldn't be bothered to work out fractions. So you just either finished your job or you left early. Of course, if you left when you were scheduled to leave and your job wasn't done, you got in trouble. But you didn't get paid to be there and finish your job. The argument was you should have finished your job in that time. But that's another story for another day. In this case, for the purposes of this argument, to teach you the math behind it, the lowest amount I can work in a day is 0. The highest amount I can work in a day is 8. What are the other values that I can put in there? Is it every single possible time from 0 to 8 that I would be paid for? Yes. Nowadays, in the 21st century, rounded to the nearest second, right? You could round it to the nearest second.
That's crazy.
Right?
I like 15 minutes when I was
You wouldn't need to. The way they would usually do it now, they'll go to a quarter of an hour. But if you got a computer, you could go down to the second, right?
That's a little bit excessive.
Now, it is excessive because a second is 1/3600th of an hour, correct? You cannot divide 950 by 3,600, and get a viable piece of currency, can you? Right? What's the smallest amount of money we go in? Cents. So if you were to divide that by 100, you might be able to divide this time by 100. Does everybody understand? In reality. But for teaching math, and if we're going to work in our heads, and I am paid by the whole hour, what are the numbers that would go in here? No. We're on domain. Domain is the independent variable, just hours. 1, 2, 3, 4, 5, 6, 7, 8. Does everybody understand? The person that runs Flying Wedge Pizza, which actually used to be in Abbotsford, and it is spectacularly good pizza, but it's closed because people in Abbotsford don't really want to pay $10 for a slice of pizza. I don't blame them. Flying Wedge slices were very expensive, but they were gigantic, and they were also very delicious.
How big?
But in this city where you can get a slice of pizza for $1.25, having slice of pizza for like $6 was it wasn't a good business model. There's Flying Wedges in Vancouver that do fine because people are used to paying those prices. At any rate, does everybody understand this? The manager of this Flying Wedge says, I don't want to be bothered with fractions. I don't want to use a computer. I'm going to schedule you for a whole hours only, and that's what you're getting paid. Is everybody cool? Because I can only pay you 0, 1, 2, 3, 4, 5, 6, 7, 8. Once you go past 8, I got to pay overtime. Does everybody understand? All right. So these are my domains, which also means that they are what we call our input. because that is what you are putting in to get an output. What is your output? Your pay. Because your pay depends on how much you work, which is your input. Is everybody cool? So what then are my ranges? And I got to use these squiggly brackets. What is the lowest amount I can be paid? 0, because I can go to work that day. Then what's my first range value? 950. Second range value? 19. Third range value? 2850. No, yeah. Next range value? 38. And so on. I'm going to run out of room. Does everybody understand? Up to what value? Whatever 8 times 950 is, which is 8 times 9 is 72, $76. Does everybody understand? Okay. Is it a function, yes or no? Why? But that's a relation.
Oh, okay. I forgot what a function is.
Is this a function? A relation is when one relates to the other. A function is a special kind of relation. If you don't remember, you should look back a page in your notes. Oh, by the way, I didn't finish marking your test. That's why we're not going over it. What's a function?
Well, it's not a function because there's a dependent and independent variable. For it to be a function, you would have to look at any variable on both sets and be able to relate it to another variable on the other set.
A specific relation whereby each variable relates to a unique variable in the other set. Does 0 relate to a unique value over here? Right. If I don't work, I get 0 money. Does 1 relate to one value over here? How many values does 1 relate to? One other value. So is that unique? So is it a function? Yes. Why is it a function? Every element of the domain or input relates to a single element of range or output. Everybody cool? Everybody cool? Okay. What's weird about number 4? Why is number 4 weird? You don't have any units. Right? But you have seen stuff written this way before in math. They're coordinates, right? What's first in coordinates? X. So X must be my input, correct? So X must be my domain, correct? So 1 relates to 3. Is that a function right now? Yeah, because 1 relates to 3. My input of 1 gives me an output of 3. There's no other input that gives me an output of 3, correct? So that's a function. What about this one? 2 is a new input, and it gives me a new output. So that's a function still. What about 3?
Uh-oh. It's not the whole set thing isn't a function anymore because when you're talking about 3, you could be talking about X or Y.
No. 3 is still X. 9 is Y. Does 3, a new input, give me a new output? Yes or no? Yes. Does 4 give me a new output? So is it a function? Yes. This one's a function. Why? Each input gives one output. What's the domain and range? What is my domain here? 1, 2, 3, 4. What is my range? 3, 6, 9, 12. Now, here's a mistake that all of you make on a regular basis. Not all of you, but a lot of you. Here, they're paired up, aren't they? In ordered pairs. X, Y, IV, DV, domain value, range value, right? But once you split them, they are no longer necessarily pairs. Because we always write domain and range in ascending order. So we put our lowest domain value first and then we go up. Everybody cool? So in this case, it happened to work out as pairs. Everybody understand? But what if I had this? Oops. No, that can stay there, damn it. What if I had this? Does it?
Yeah, because when you
what is our new first domain value? -5. Where does the 15 go? No, it would go ascending order. 3, 6, 9, 12, 15. See how that's at the first and that's at the end? They no longer make up their pairs?
I thought you said with ascending order that you count digiting of the sign, or was that just with listing of factors?
That was a factor thing. Does everybody understand? Even though it's a pair there, it doesn't make a pair once I list it. Because domain and range are only looking at the values in domain, all the inputs, and the elements in range, not the pair. Everybody cool? All right. Look at B. You tell me, function or not? Function or relation? It's a relation. It is a relation. Why? For which input?
0.
Right. Input of 0 gives me how many outputs? 2 outputs. It gives me an output of -1 and 1. So when I say I'm thinking of a value and I've input 0, what am I thinking of?
You can't tell.
You cannot tell me. What about C? It's a function. Why? Input gives 1 output. Everybody cool? Can everybody do this with a list now? Great. Now we'll shift gears and go to a graph. Did I give you a tool to check on a graph? No, not yet. So we got to check everything, don't we? Where are our inputs? X. So there's one there, right? Right? Does everybody understand? Oh, we're supposed to be doing the domain and range too. Is there one there? Is there one there? 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 Oops, sorry, I'm on the x-axis. There and there, correct? So, input of -3 gives me 1 output, correct? So I'm okay. Input of -2 gives me what? Gives me 2 outputs. So what is it? It's a relation. Because at input negative 2, I get 2 outputs. Now, you guys tell me the domain and range here, because I got to pee. Go.
There is no God.
Got it?
That was fast.
Yeah, I'm the Flash. What's the domain?
Oh, I thought about that. Did Flash's key go faster?
What's the domain?
Negative 3.
Negative 3.
Negative 2. Do you repeat or not?
The domain is just the elements that are in the independent variable.
Okay.
So
So then 0, 1, 2, 3.
nice. What's the range? Negative 3. Negative 2. Negative 1. Nice. Is everybody good? Now, how did you know from the graph that it was a relation?
So you already saw 2 different outputs on the X.
Because when you went to here, you noticed there were 2 outputs, correct? So on a graph, it was really easy to see, right?
Yeah.
Because if I draw this line at the input of negative 2, I hit 2 outputs, don't I? If it happens once in math, how often does it happen?
Every single time.
Damn right. So that gives us the vertical line test. On a graph, please remember this only works on a graph. A vertical line
That looks cool. I like that. Are we allowed to have those squiggly lines on graphs?
Sure you are. It depends on your data. Now, observe. Vertical line, yes? How many times does it hit the red line?
He's always hitting the red line.
once. So is this a function or a relation?
Function.
Function. Are you guys done? Let me give you the most important piece of advice that I could ever possibly give you, even though nobody in the world follows it. Neither one of you is going to change your mind, so stop arguing. Okay? That's where the joke on one of my favorite TV shows comes from, where the guy says, it's impossible. It's like somebody on the internet saying, you're right, you've convinced me, you've changed my mind. It's not going to happen. Okay? No matter how much science proves that somebody was on the moon, there are people that think there wasn't someone on the moon. No matter how much science proves that vaccines don't make you sick, people still aren't going to get vaccines. It doesn't matter. Just accept it, because no one's going to change their mind. What happens here? Function. Ah! Relation. Why?
I don't know.
Because at that input of 5, I have 1, 2, 3 outputs. So that is a relation. Is everybody good? Yes? Excellent. You now do 5 by yourself. And on 6, you just tell me if it is a function or not. You won't be able to list the domain and range because I haven't taught you how yet. Go.
So what, you should connect the dots or something?
You do not, which is a very different thing.
I tried coding in middle school. It was weird.
All right. Everybody cool? Everybody cool? All right. What then is the domain? -3.
-2.
-2. -1. 0. 1, 2, 3. 1, 2, 3. Lena Goot's not even here for me to show off my German.
What did that mean in English?
1, 2, 3.
Whoa! That was amazing, Myers.
I can count to 5. Then no further. 1, 2, 3, 4, 5. I can also count to 10 in Japanese and Spanish. Ich, ni, san, shi, go, rok, sich, hach, ku, ju.
Wait, was that 5? That sounded like...
Bro, where? You can count.
That was 10, dude.
Okay.
That was 10.
It sounded more than 5.
What is the range?
-2.
-2. -1.
0.
0. 1. 2. 3. 1, 2, 3. Is everybody good? Everybody? All right. Now I asked you to do one more thing with B, and then I had to help you. What is this? Function or relation?
Function.
Why?
Because the dots are not overtopping each other.
Because the vertical line only hits the blue line once at any given spot. Yes?
Yeah.
Okay. Now, this is where it gets a little weird. The domain lives where?
X.
On the x-axis. What is the lowest x value?
-3.
-3. Everyone agree?
Yeah.
Now, if it was this. One sec.
What, are you going to make vertical lines?
No.
Wow.
If it was this. What would the range or the domain be? -3, -2, -1, 0, 1, 2, 3. Correct? Everyone agree? And it would only be -3, -2, right? Because you can quite plainly see that there are no outputs until we get to there, correct? So I have to write numbers with commas, yes? Everybody agree? But that's not what it is it? I have an x value all the way along, don't I? Is there always an x value? So does that include the fractions? The decimals? Down to what fraction? Right. Every single possible value of x, including the 1 bazillionth fraction of x, yes? So I cannot write 3 or -3, -2.999999 forever, comma, -2.999999998, -2.9999. I can't write that, can I?
You just use a line.
Yes. So this goes from -3 all the way up to +3. And at every spot, I have an input. Does everybody understand? Domain values are x's, yes? Those values, -3 is the lowest. So -3 is less than or equal to x. And x is less than or equal to what? +3. Does everybody see that? Yeah? This, once we put squiggly brackets around it, is what we call set notation. Now, it gets written much more fancy-like as you get older. But for now, this is the concept that I want you to get. What it looks like when you get older is they do this. You say y, or sorry, not y, because we're x's. X, because that's what we're measuring, x's. That vertical line means is a set. Where -3 is less than or equal to x, which is less than or equal to 3. And then x is every real number. That means every, and that means real numbers. This is the really advanced way of writing it. I don't care, and nor should you, unless you go further with set theory mathematics, which isn't until significantly later. Okay? For me, all I need is that part. But that's what it looks like properly. Is everybody good? Great. Now use your brains and figure out the range. Try to write it in the same way. -2. Less than or equal to y, and y is less than or equal to no 3, because it goes all the way up to 3. Is everybody good? That is called set notation. There's another way to write this because math guys are lazy. Okay? And I'm going to show you that in a second after I let you try the set notation one more time. Now, look at B. Everyone's cool with it, right? Look at C and tell me what's different. I'm going to shrink it down so I can have them both on the screen at the same time. What is different? They're not connected. That's one difference. So that means I must have a domain here for that line and another domain here. right? That's one thing that's different. What else do you see that is different? Luke.
It's not a function because it's going to hit twice.
Where?
There, and then it's going to disconnect.
Vertical line only hits it once. Vertical line only hits it once.
So those are two different graphs then?
No, that's the same graph.
Well,
But there is no data in here. But it's still a function because I only have one output for every input.
Okay.
What else is different though? Look closely. Jazreet. Empty, colored in. Where have you seen that before?
I just found another difference.
Negatives and positives in algebra tiles? Yep. Anywhere else?
I see that it goes up by 10 each notch.
Aren't they on the graph?
Yeah, who remembers this?
Yeah.
That minus 2, x is less than 7. And then we graph it. 7. Less than 7. Is 7 included? No, because 7 plus 2 is 9. It's not less than 9. So we put an open circle. 7's not included. Is 6.99999999999999999999999 included? Yes. Everybody understand? So, knowing what you remember from grade 9, try to tell me the domain of this graph. Go. Talk to your neighbor if you need to. I haven't taught you how to write it properly, so just use as much math knowledge as you can get into your head, or out of your head right now. Would anybody like to volunteer what they think is correct? Don't be wussy. Going once. Going twice. Gummy bear for anybody who will offer. Still only one person, surprising. Joy. Negative 30 less than or equal to x. And then you're very close.
Less than or equal to 0.
Closer still. Less than negative 10. Why?
There's no data after negative.
Open dot, and there's no data in the middle here. Everybody understand? That covers this part. But what happens right here? It starts again. What's the lowest value?
10.
Is 0 included? Yes. Less than or equal to x. Up to what? Is 30 included? No. So I can't have the equal sign. Joy, go get your gummy bear for having the guts to do so. Does everybody understand? Now, this is two subsets of the whole domain, isn't it? So we put a U in the middle of it because it is that set and union that set. Everybody understand? Is everybody okay? And of course, these should have squiggly brackets. Is everybody good? Everybody good? Okay. What's the range? Now that you've seen how to do it, try and do the range. Would anybody like to volunteer their attempt at range? Harmon, Beauparis, Beauparu.
Negative 20, less than or equal to y, less than 0. And then I have the,
Union.
yeah. And then negative 10, less than,
Negative 10
or 10, less than or equal to y,
equal to
less than y.
less than y, because it's an open dot,
And then
up to
less than, equal to
30.
30.
Does everybody understand?
I did backwards for the second.
Now, remember how I said there's another way to write this because math guys are lazy? Okay, this is set notation. Let's go back to this one. We also can do what is called interval notation. And interval notation only works with lines. You cannot do it with dots. And you do the same thing. You put the lowest value first, -3. The highest value second, 3. Since they were both included, closed dots, we use square brackets. That means every value between -3 and 3 and including -3 and 3. That was the domain. What then is the range? -2, comma, 3 with what kind of brackets? Square brackets. Because they're both included. Everybody cool? Now do that with these guys. What's this? Goes from what to what? -30 to -10. Which one is included? The 30, so it gets a square bracket. -10 gets a round bracket. Because it's not included.
That's a little harsh.
Okay? What's this one? Well, this is math, not elementary school in North America, where everybody has to be included, where they actually have rules. Like, you two don't like each other, but you still have to play together. What's this? 0, comma, 30. Where are the brackets? Square, round. Everybody got it? What's the range?
-2, comma, 0.
Square bracket, -20, comma, 0, round. Union. What kind of bracket? Round.
What?
10, 30, square. Can everybody do both?
Kind of. That looks so.
Everybody cool? Yeah, yeah?
And then the belly button in the middle. Like in the middle with the union in the bracket?
I am looking at my belly button as we speak.
No, like it looks like a whole abdomen. Like not a whole one, but like this section.
Oh, you mean like if you drew a person and then the butt would be there, but we're looking at him from the front. Legs would go down there, legs there, and then what's between the legs? And then arms here and shoulders there, and then this would be, yeah, because right here are your hips and there would be a belly button. I read you. Okay.
Look at it for a second.
And then here would be boobs. Yeah. And if you're a boy, you'd have chest hair and armpit hair and then a smiley face. And if you were a girl, you would have no chest hair and no armpit hair. But you might if you were from Europe.
Wait, why was his face on his chest?
It wasn't. That was the nipples and the belly button.
But you said a smiley face.
Oh, because once I drew it, it looked like a smiley face. Because once I put hair above the nipples, when you put the hair above the nipples for chest hair, it looked like hair on the head. But none of you have chest hair yet because you're boys. You're not men. Don't show us. It's fine. It's 2?
I can pull it out.
I wouldn't.
And I have beard too.
You should be proud of that. That's your man hair.
That's my man hair.
I don't understand these dudes that shave every square millimeter of their body.
I mean,
I am not a swimmer. I do not need to shave 1,000th of a second off my swim time.
7-inch long chest
All right, moving on. Computer's frozen. You guys look at D, because D is so crazy.
There's going to be 3 union sets.
Look closer.
4.
Look closer.
7.
Look closer. First of all, is it a function or a relation? Why do you say relation, Joseph? Because a vertical line hits twice right there, yeah? Does it? Look closer. Why not?
Open dot. And it's before it.
That's an open dot.
What does this have to do with math?
So this is still a function because at input -3, we only have one output because 3y equals 6 doesn't start until when? Until after -3. Like -2.99999999999999999. Everybody understand? Everybody understand why that's still a function? Great. Now, let's address what Luke just said. Luke said I will need 3 union sets. Well, let's check, shall we? What is my lowest y value?
1. 1.
What is my lowest x value?
Oh, wait, no. Negative y value is 3. Negative 2. No, negative 1.9999999. No, lowest y value is...
I've changed it. Lowest x value.
Lowest x value is -6.
-6.
Bro, where? Oh, that's 3. I just realized that.
Is it included?
No.
No. Now let's go along. Do I have a domain value all the way to there?
Yes.
Do I have a domain value right after that?
No.
Sure I do. It's right there.
Okay.
So I keep going till here. Do I have a domain value there?
Yeah. Yeah, sure.
So, do I need any union sets?
No.
No, because that's a straight line.
That's cool.
What is my lowest value in set notation? -6. Do I hit -6? No. So what arrow is it?
Less than.
Less than? Excellent. What am I counting here?
Oh, yeah.
X's.
Bracket first.
Well, we're not doing that. We're doing set notation first. What does x go up to? Do I hit 6?
No. Yeah, you do.
So it's the equals one. Now do that in interval notation. Do I hit -6? So what bracket? Roundy. -6, comma. Do I hit 6? So what bracket? Squarey. Everybody good? Now look at the range. What is my lowest range value? What is my lowest y value?
3.
3. 3. What is my next y value? 6. Are there any y values in the middle? No. So can I do set or interval? I can only do one of them. Which one? Set. Can I use the arrows? No, why not, Anish? There's nothing in between. Y can only be 3, 6, or 9. Does everybody understand? Everybody's good? No, you can't do that because it's not an interval. It's only 3 values. Everybody understand? Okay, now, when I leave that much white space, why? Because there's some kind of craziness that goes on beyond the regular. Okay, everybody ready for it? Draw an axis. Each square is worth 1. Has everybody drawn this? Yeah? Yeah? Okay. Now draw the following line. At -3, -3, start the line. Draw any kind of line you want up to +3. Doesn't matter what you do. Everybody okay? Everybody good? Okay. Now, come down in any kind of line and end up pointing down and to the right. And put the arrow on the end. What does that arrow mean? In what direction? What directions? Down and right. Everyone agree? Okay. So, what in this case is my domain? Where do I look for my domains? X-axis. What's the lowest x-axis? -3. And then I go this way. How long? It never stops because that arrow continues to point to the right. Yes? So what then would my domain be? What is the lowest value? -3. Which is lower than, is it equal to?
No.
Is that a closed dot? Looks like a closed dot to me, so is it equal to? X's. And what am I going up to? Infinity. Will I ever get there? No. So I will be less than infinity. What then is the interval notation for that? Done. Now, here I have to show you something else. That can also be written as x is greater than or equal to -3. Why? Why is this okay? Damaris, finish it off. Yes, because as long as x is greater than -3 all the way to infinity, you're okay. So you can write this in a shorter version. It just depends on what your textbook or what your question, who wrote it. Does everybody understand? Everybody good? Okay. What's the range? It's tricky. What kind of infinity? Right. Negative infinity, because it goes down and we put the lowest value first. Do I ever hit it?
Never.
Y less than or equal to what? 3. Squiggly bracket. How can I rewrite that tidier? Y is less than or equal to 3. Because the infinity is covered. Everybody good? How do I write that in interval notation? Round bracket, negative infinity. 3, square bracket. Everybody good? Everybody? All right. You have 20 minutes. You are going to do these 2 sheets, which I'm going to talk about in a moment, and page 177. You're going to do 175, 76, and 77. Listen, please. The photocopying isn't very good. So you will notice I've made some changes. All right? I want domain and range in every possible notation you can do. So if you can do set, you do set. If you can do set and interval, you do both. Does everybody understand? Now, let's go through this. Please notice, in number 2, the dot right on the y-axis is open. I don't know how well that photocopied on your book.
I don't even have the same.
Oh, crap. That's the second page. Sorry, first page. First page. Here we are. Everything in the first 3 is closed dots. This line flattens out. It does not continue downwards. Everybody good? Everybody cool? This is flat. In number 4, this is an open dot. I don't know how well it photocopied. Can everybody see that's open? Okay. This one, I'm going to say that is also flat. And these 2 are both closed. Is everybody good? Turn the page to page 2. Open dot right on the y-axis. Is it visible in the photocopying? Yes. Closed dots everywhere on 3. Closed dots. I think you have an arrow there or was something that looks like an arrow on the left. It's supposed to be a dot. Everybody good? Down here, these 3 are all open. And these arrows are actually there. Yeah? Everybody okay? Everybody good?
So is this an arrow in the middle or is it just a dot?
These are all open dots.
And then the left of them is just one arrow and then the other 2 are closed dots, right?
Yep.
Right.
5, open dot. Everybody good?
Why is the 6 is just
6, you just got to try and figure out. It actually is when you think about it. Everybody good?
You have to use pi.
Did I ask for the area of the circle?
No.
So would you have to use pi?
No.
Go.